What if I told you that 16 AI agents just built a working C compiler from scratch, and it actually works? Not just compiles Hello World, but compiles the entire Linux kernel. This isn't a benchmark score or a tech demo. It's 100,000 lines of real functional code that took 2 weeks and $20,000 to create. The experiment run by Anthropic researcher Nicholas Carlini is raising serious questions about what AI can actually build when you let it loose on real engineering problems. But that's just the beginning. Because while software AI is writing compilers, physical AI is coming for factory floors, and trade unions around the world are sounding the alarm. Let's break down what actually happened here. Nicholas Carlini, a researcher on Anthropic's Safeguards team, set up an experiment using Claude Opus 4.6, Anthropic's most capable AI model. But here's what makes this different from typical AI coding demos. He didn't have one AI writing code. He deployed 16 separate Claude agents, each running in its own isolated Docker container, all working on the same code base simultaneously. The task? Build a complete C compiler in Rust from scratch, capable of compiling the Linux kernel. No internet access. No copying from existing compilers. A clean room implementation using only the Rust standard library. Over 2 weeks, these agents ran nearly 2,000 automated coding sessions. They picked their own tasks, coordinated through Git, resolved their own merge conflicts, and pushed code without human supervision. Carlini wasn't pair programming with them, or reviewing pull requests in real time. The agents were essentially self-organizing. The result is what Anthropic calls Claude C compiler, 100,000 lines of Rust code that can compile the Linux kernel on x86, ARM, and RISC-V architectures. But it doesn't stop there. The compiler can also build QEMU, FFmpeg, SQLite, PostgreSQL, and Redis. It achieves a 99% pass rate on the GCC torture test suite, a collection of edge cases specifically designed to break compilers. And in what Carlini calls the developer's ultimate litmus test, it can compile and run Doom. The total cost, just under $20,000 in API usage, consuming 2 billion input tokens, and generating 140 million output tokens. The complete source code is now available on GitHub for anyone to examine. This matters because it's the first concrete proof that multiple AI agents can coordinate to solve genuinely complex systems-level problems. Building a C compiler isn't writing boilerplate code or generating React components. It's real systems engineering, parsing, type checking, code generation, optimization across multiple architectures. The kind of work that typically requires senior engineers with deep expertise. But let's be clear about what this is and isn't. This wasn't fully autonomous. Carlini designed the testing infrastructure. He set up the continuous integration pipelines. He created the harness that kept agents focused and prevented them from wasting hours on unproductive paths. The agents couldn't tell time, and would happily run tests forever without intervention. The compiler also has gaps. It can't boot Linux from real mode. It calls out to GCC for 16-bit x86 code. The assembler and linker are still buggy. The generated code is functional but less efficient than even unoptimized GCC output. What this demonstrates is the current state of AI-assisted development, capable of impressive output when given strong scaffolding and clear objectives, but still requiring significant human oversight to be productive. The $20,000 price tag also matters. This isn't cheap, even by enterprise software standards. Watch for how developers respond to the open-source release. The code is on GitHub right now, and the real test will be whether the community can extend it, fix the remaining bugs, or use it as a foundation for other projects. Also keep an eye on costs. If multi-agent approaches become more efficient, the economics of AI-built software could change dramatically. Carlini himself said he didn't expect this to be anywhere near possible so early in 2026. That should tell you something about how fast this field is moving. So AI agents can now build complex software systems. But software is just one half of the automation story. The other half, the part that affects the majority of the global workforce, is physical labor. And that's where things get really interesting. Because for the first time, organized labor is pushing back against a new wave of AI that looks very different from chatbots and code assistants. Trade unions around the world are raising alarms about humanoid robots designed for blue-collar work, calling it, and this is a direct quote, a whole other challenge on top of large language models. This isn't theoretical concern. Conflicts between companies pushing humanoid robot adoption and unions opposing deployment are intensifying globally. The United Steelworkers in the United States is in final stage negotiations over AI technology adoption, threatening strikes over what they call management's foot-dragging on employment protections. German automakers Stellantis, Mercedes-Benz and BMW are locked in standoffs with unions. SAP and Lloyds are facing similar pressure. But the flashpoint is in South Korea, where Hyundai Motor announced plans to mass-produce Boston Dynamics Atlas humanoid robots at a new U.S. plant by 2028, with gradual deployment across its assembly lines. The company is promoting this as the cornerstone of its physical AI's future. South Korean lawmakers have now introduced legislation requiring the government to protect workers from AI-driven job losses and support transitions to new roles. The numbers driving this are stark. Industry analysts estimate each Atlas robot costs about 14 million won, roughly $9,700 in annual maintenance while operating nearly 24 hours a day. Compare that to a human worker costing Hyundai about 130 million won per year. The math is brutal. Yang Kyung-soo, chairperson of the Korean Confederation of Trade Unions representing over 1 million members, put it bluntly. The introduction of AI without a labor management agreement will rapidly destroy jobs and create a new underclass living in extreme poverty. And here's the global context that makes this even more significant. Chinese companies now control nearly 90% of the global humanoid robot market. Shanghai-based Agibot alone shipped over 5,000 humanoid robots last year, capturing roughly 39% of global market share. Unitree shocked the industry by launching a humanoid robot for just $5,900, a price point that seemed years away. This is fundamentally different from the AI anxiety that dominated headlines over the past few years. When ChatGPT launched, the fear was about writers, coders, and knowledge workers. Those jobs can theoretically be reskilled. People can learn new tools, shift to adjacent roles, work remotely while adapting. Blue-collar work is different. Factory workers, warehouse operators, assembly line technicians, these jobs can't be done from home. They require physical presence. And when a robot can do the physical task, there's no hybrid option. Unions face what analysts are calling an impossible dilemma. If they accept humanoid deployment, they gradually lose the workforce that gives labor movements their foundation. If they resist, companies relocate production overseas, leading to immediate job losses anyway. Either path leads to damage. This is also the first time organized labor is responding to physical AI as a category distinct from software automation. The Hyundai situation isn't about chatbots taking customer service calls. It's about robots taking positions on assembly lines where humans have worked for decades. That's a different conversation with different stakes. Watch South Korea closely. The legislative push for worker protections could become a template for other countries. If Hyundai's 2028 deployment timeline holds, you'll see this fight intensify over the next 2 years. Also track Chinese manufacturers like Agibot and Unitree. Their price points and production capacity will determine how fast humanoid robots become economically viable for widespread deployment. The question isn't whether robots will enter these workplaces. It's whether workers will have any seat at the table when they do. AI is building compilers and walking onto factory floors. The question that keeps coming up is whether humans will be partners in this transition or passengers. That's the conversation that matters most right now. If you want to stay on top of these developments as they unfold, hit subscribe. This channel covers AI and tech news daily. See you in the next one.